Hi, and welcome to the evening shift here in my shop. So something got me pretty curious about this radio. In the last video, I changed the two capacitors that protect or block B plus from reaching the grids of the two output tubes, which are right here. Before I did that, I took a reading of the grid voltages for the two output tubes. And I got, I can't remember the exact amount, something like a volt positive. When you really should get nothing, it should just be 0. Volt positive. So I thought, well, maybe that's evidence of the capacitors leaking. And then remove the capacitors, put new ones in. The new ones are not old, they're brand new manufactured capacitors of very, very good quality. So the ones I took out, I put on a capacitor tester. And, they weren't the worst. And the odd thing was, if I remember right, the leakier capacitor, according to the capacitor test, was on the grid that was less affected by positive voltage. The leakier capacitor, less effect. Didn't seem right to me. But anyway, I put in the new capacitors and then turn the radio on, test the grids again, fully expecting to see a 0 and a 0. And I got a 0 and a little bit of positive voltage. Again, I can't remember how much, half a volt, I can't remember. The bias for these two tubes is created using a cathode resistor, which raises the plate positive, makes the grid look negative. But the grid is actually at chassis potential. There's a roughly 500 kilo ohm grid leak resistor, one for each tube. And I thought, well, aha, that grid leak resistor's gone open or something's going on there. I tested them, they both test fine. There's nothing wrong with the grid leak resistors. So the question remains, and this is the part that I've been pondering, how come a little bit of voltage on one grid? So one possible answer is I just booted up the test. So I'm going to get this ready to repeat the grid voltage test, and we'll take it from there. I was just taking a quick peek at the schematic here, and I found some interesting information. I don't know if I've ever seen it marked on a schematic before. This note, minus 19 volts, approximate maximum AVC. Well, that's kind of interesting. We also have a 3 volts fixed bias for gain data. So at the top of this schematic, they give you a hint as to how much gain you should see with each stage. And this is another way of localizing trouble in the radio. And so, but you can't do these measurements properly if the AVC is operating and varying the gain of the tubes you're trying to understand the circuits around. So you just take I guess literally a 3 volt battery and force this line to 3 volts negative, and then operate the radio. Well, that's kind of interesting though, minus 19 volts. I just realized the reason it's so interesting to me is I'm working on another radio. Yeah, that's the issue with that other radio. Nevertheless, you don't normally see this kind of information. At least I don't recall seeing it. Interesting stuff. Well, what I was doing was I was just studying the grounding in the radio. Make sure I'm doing these measurements correctly to the chassis. This has to mean to the chassis. They're all over the place. Okay, ready to start here. So this is the one that's up in the top corner of the screen, and it's set to 15 volts full scale right now. We're ready to switch this on through the dim bulbs. Okay, all is good. Let the tubes warm up for a moment. A little project for tonight, maybe. Okay, so I'm gonna get on one grid here. I don't see anything. The other grid here. don't see anything. Okay, maybe it was a false observation. Let's try that again. This grid. Yeah, there's a little voltage there. The meter's now on the 1.5 volt scale, so this is so 1 volt is way over here. So I can kind of start thinking about getting ahead of myself here. 1 volt's over here, so this is 0.1, 0.2. Why it just jumped there? That's curious. I'm wiggling things around a bit. That's quite curious. I'm going to go back to the other grid. And there's a little tiny bit there too. 0 meter better. It's a tiny, tiny amount. Where would that come from? Okay, so I'm going to keep track of which is which. Whoa! Whoa! Going to keep track of which is which. I'm going to switch the tubes and see if the voltage changes. So the way I'm going to do that is make a little diagram here. The 2 tubes. Okay, repeat the measurements. This is the higher one. And the voltage we're getting there is, to write it down properly, 0.4 volts. 0.4 volts on this tube. Okay, and the other tube. Okay, so we're getting 0.04 volts, I'd say. Okay, we're gonna switch the tubes around. Those are probably pretty hot. A lot of protection in this. K6, that's what it's supposed to be. Yeah, just a little too hot. 6K6. Exciting stuff. Back on with the power. Oh yeah, I was going to clean that. Do that next. Do it right now while it's warming up. Yeah, darn it. Okay, well that noise is supposed to go away pretty quick. There we are. That's a lot better. Okay. Now the tube should be operating so we can make the measurements. Okay, this one was the 0.4. Yeah. It's absolute 0. Try it again. It's a tiny amount there. And the other one, 0.4. Same as before. That's mighty curious. Oh. I was just saying, okay, I'm going to try and get away with this. So I've got this set up for 6K6. I'm going to double check it. 6K6, we're going to ignore my cat. Sometimes he'll just go away too. 46H when he realizes I'm paying no attention whatsoever. Yeah, 07345. 07345. 0610. 0610. Just ignore. Just ignore. 43. And 44 and F. I don't want to look at him. Don't look at him. Okay, switch on. So this tube, 6K6, is the tube that drives the speaker with its buddy, the other 6K6, the two together. Kind of give it the heave-ho. 1360. So when we do the test, then we will want to get to 1360. So 1000. That's 15 there. So 1360 about here. Is that right? Okay, first we'll do the. Are there any shorts in this? Oh, I've looked at them. I've looked upon them. Okay, here we go. So I make that out to be 11, 12, 1250. Okay. So the number I gave earlier is the reject point where you should think about getting new ones. Or I think maybe back in the day that was the selling point. Good show, we can sell a new tube. But I mean, even if they're only working at 50% of their capability, it's probably still plenty. And assuming the radio is only going to be played occasionally, which maybe isn't a good assumption. These got lots of miles in them, probably. Okay, do the short test. Here we go. Take a close look this time. So this one is stronger. This is up around 1500. So I want a little stronger than the other, but not a real problem. Okay, Peanut, I am coming. Okay, Peanut, come on over. Show your face. Show your face. There it is. Okay, 6SQ7. 6.31, 25100, 3760, 3760. I better double check my double check. I think 37 F. We're good. No short showing up. This tube should test at 760. It should be about here, way above. Okay, now I have to pull it out, make some changes. Or we'll just put this one in. Let's do that. Oh boy, it's way down there. It's still coming up though. That's pretty low. Quite a difference between these two tubes. 760 is the throw it away point, so right around here. It's right on the throw it away point. The operation of the radio could be affected dramatically if I just swap these two tubes around. I didn't pay close attention which tube came out of what spot. Okay, so we'll do the diode test. This is the weak tube now. Two 013P. 2013P. 3760. 3760. That's not right. 0760. 0760. 48. F. 48A. A. That's to change. So we're doing P1, P2, two diodes in there. Okay, check for short, so put a tube in. Go back to doing the weak tube. Now shorts can develop in a tube after it's been operating for a while, so this short test really is just to protect the I mean, you can find shorted tubes, obviously, but also you're protecting your tube tester by doing that. Diode just has to get above here. It's low. P1, P2. So this tube really needs to be replaced. Okay, so we're going to put the bad one over here, put the good one in. Do the diode test on here as soon as it warms up. It's above the diode OK line. Likewise there. So one tube worn out, the other one not. 6 SQ7. I think I got a few of those. Put the good one in, set the bad one aside, and now we're going to go after 6SA7. Okay, I'll get that set up. Okay, just about ready on the 6SA7. We'll just double check this. 6.3, signal level 2. Bias is 9 low. 27345. 27345. 1650. 1650. Very good. 45. We're ready. C. We are ready. This tube should be above 1100, above here. Oh, wow, that's a beauty. Okay, and now the last tube here. Bet you it's a 6SK7. 6S. Can't read it. SG7. Okay, I'm gonna guess that. 6SG7. There it is. Just keep the camera rolling here. 6.32, 10 L, 10 low, 2715 K, 2715 K. 4630. 4630. 29. C. Okay, I think I got it right. sorts. 6SG7, 1380. Just about up to here. Whoa! Okay, double check everything. That is really low. There's two tests for this. K1 and K2, so there's two cathodes in the other one. It's a dud also. Okay, let's just check things out here. 6.32, 10L, right? 2715K, 2715K, 4630, 4630. Setting over here should be, oh, this is a low. No, it isn't. 29. That's correct. And C. She's a dud. She's pretty bad. That's really weak, because the throw it away point is way up here. I mean, this is really bad. It's warming up, but it's no good. Okay, so I'm gonna have to stick a couple new tubes in this radio. That'll be 3 tubes altogether. I'll get another one of these, and then, I think I got one. We'll see. I will check. Okay, let's try this 6SG7. Good. Okay, so I have a good 6SG7. Interestingly enough, somebody's written okay on the top of it. They're right. So I'm going to put that in. And the other one we need is a 6SQ7. So I'm going to take one of those out. Okay, possible replacement 6SQ7. And gain 760. Well over. Very good. That'll do it. Won't need that one. Very good. Well, I think it's worth a try at playing this radio. We'll turn it off. Plugged in. There we go. Now we know it has a good complement of tubes in it. I don't have the antenna connected. Ah. Okay, we'll turn it up. Change bands. Aha! That's got to be phono. Full volume, but this band is silent. Zero. Let me be the antenna here. I'm a lousy antenna. Let's let the antenna be the antenna. This goes to an outdoor antenna. Nothing. Silence. Get back to the middle. Well, I don't know why one band would be silent, but let's put the antenna on it. I'm just dying to find out what happens on AM with a proper antenna there. Let's try once again. So this time I have the antenna connected. Volume's not up that much. Very, very directional antenna. That's good enough. That proves a lot of stuff is working. Good. That's good. Okay. Now we can continue with the replacement of the capacitors. We'll finish off doing the audio side and see how that comes out, and then it's on to the radio side. Great. Thanks a lot for watching.